Hello everybody. This week we're going to be doing volumetric analysis in our Labflow lab, and I wanted to take the opportunity to do a little video and explain a couple of things for you guys. So for part A, what we're going to be doing is standardizing our sodium hydroxide. We do this because sodium hydroxide is not a primary standard, so we can't trust that we can just weigh out a certain amount of sodium hydroxide, dissolve it in a certain amount of water, and really know the concentration. We have to have a primary standard like our KHP to titrate against in order to accurately determine our sodium hydroxide concentration. This is going to be our experimental setup. We're going to have a burette. It's marked out in milliliters. To it, we're going to add the sodium hydroxide that we want to determine its concentration. In our flask, we're going to weigh out some solid KHP, certain mass. We're going to add some water to dissolve it. It doesn't really matter how much water we add, just so long as it's enough to get the KHP dissolved. In addition to that, we're going to add an indicator. In this case, we're going to use phenolphthalein. It's going to turn the KHP solution from clear to pink when we've reached the endpoint, and the moles of sodium hydroxide are equal to the moles of KHP that we've added. From Labflow and our provisional data, we're going to have some variables that we're going to be given. We're going to be given the mass of our KHP. We're going to be given the initial volume that we filled the beer up to, and we're going to be given a final volume. It's a measurement we're going to make after we drip some sodium hydroxide down into our flask. The first thing you're going to be asked for is going to be the volume of sodium hydroxide that you added. And that's going to be our final measurement minus our initial measurement. And that's going to be in milliliters. Next, we'll need to know the moles of KHP that we added. We're going to get that by taking the mass of KHP from our provisional data and dividing it by the molecular weight of KHP, which we know to be 204.22 grams per mole. Next, we need to use stoichiometry to figure out the moles of sodium hydroxide. This one's pretty easy because there is a one-to-one relationship between the moles of sodium hydroxide and the moles of KHP. So the moles of KHP pretty much equals the moles of sodium hydroxide in this case. Finally, we can figure out the concentration of our sodium hydroxide by taking the moles of sodium hydroxide and dividing it by the volume of sodium hydroxide that we initially calculated. We are going to have to do a conversion here because this volume must be in liters in order to get out molarity for our concentration of sodium hydroxide. You're going to do this 3 different times, and you're going to take an average of those 3 trials to give ourselves a really good value for the concentration of sodium hydroxide. For part B, we're going to figure out the molar concentration of an acid. We're going to have a similar experimental setup, except for this time we're going to have a solution of acid, and we're going to add a specific volume each time to our flask. We're also going to be given a type of acid, and this is a subtle thing you guys have to pay attention to. When I got my provisional data, I got a triprotic acid that was expressed this way, but you might get a diprotic one or a monoprotic one that would be expressed in one of those 2 ways. In addition, with our provisional data, we're going to be given the volume of acid that we added, the initial volume of sodium hydroxide in the burette, and the final volume of sodium hydroxide in the burette. To calculate the volume of sodium hydroxide we added, we're going to take the final minus the initial like we did in part A. They want you to re-put in the concentration, the average concentration we calculated from part A, into part B. We're going to figure out the moles of sodium hydroxide this time by taking the concentration of sodium hydroxide times the volume that we added up here. This volume, again, we're going to have to make a conversion. It's got to be in liters. That way we have liters times molarity is going to give us moles. In my case, where I had a triprotic acid, I'm going to have a balanced equation that looks like this, where I start off with my triprotic acid. I add 3 moles of the sodium hydroxide, and then I get this trisodium acid salt and 3 moles of water when the neutralization is complete. To calculate the moles of acid, I'm going to have a different stoichiometric ratio than I did in part A. Here now I'm going to have 3 moles because of this coefficient right here, and the moles of acid is going to be 1/3 the moles of the sodium hydroxide. If you had a diprotic, this would be a 2. If you had a monoprotic, it would be a 1, just like it was in part A. Finally, we'll calculate the concentration of acid by taking the moles of acid we just calculated up here and dividing it by the volume of acid in liters that we were given as part of our original provisional data. For part C, we're going to figure out the percentage of acid in an unknown solid sample. We're going to have a setup that looks a lot like our KHP setup, except for now we're going to be given this unknown solid. Some of this is going to be a solid acid, and some of it is just going to be like a filler material that's not going to react during our titration. And we want to know what percentage by mass of this sample is solid acid. Again, we're going to be given a type. When I did mine, I got a triprotic acid. And we're going to be given some other variables. We're going to be given the mass of the whole of all the solid that we added, the initial volume of sodium hydroxide, the final volume of the sodium hydroxide, and the molecular weight of the acid portion of our unknown sample. We'll calculate the volume of sodium hydroxide as the final volume of sodium hydroxide minus the initial volume of sodium hydroxide. We'll calculate the concentration of, well, we're not going to calculate it. The concentration of sodium hydroxide is going to be from part A, that average value that we used in part B. The moles of sodium hydroxide will be calculated just like it was in part B. We're going to take this concentration, we're going to multiply it by this volume that we just calculated. Again, this must be in liters. We will again calculate the moles of acid, just like we did before. Again, paying attention to whether we have a triprotic, diprotic, or monoprotic acid, and putting the appropriate coefficient in here. Finally, we'll calculate the mass of the acid by taking these moles and multiplying it by the molecular weight. So we got grams per mole times moles. We should be getting out grams. And then finally, we'll calculate the mass percent of acid in our sample by taking the mass of the acid divided by the mass of the sample times 100%.